the red dots.
Oh, that's what I'm, but
Okay.
this is the, anybody remember the mineral andalusite?
Mm-hmm.
This is the mineral andalusite, which is, remember mineralogy, what that is? Somebody's gonna spell the party earlier. No, it's aluminosilicate, but it also has, it's part of the, it's the triple, the aluminosilicates, andalusite, kyanite, sillimanite.
Oh, okay.
Sillimanite's the high temperature one, andalusite's low pressure, and kyanite's high pressure. This is andalusite with sillimanite between. And what this is the andalusites form first at temperatures below sillimanite formation.
And then under the
They
strain.
dodged and were filled with sillimanite in the necks between them, which tells you something about the temperature history of the rock. But it's an illustration of one, the biggest effect is that you can see this is stretched in this dimension. And I show that partly because it's an illustration of, it's a simple way of, you could use that to calculate stretch, right? Or strength, E if you prefer that number. But you could just take the lengths of these. There's the beards of the sillimanite on top of the andalusites. They're not andalusites anymore, they just look like andalusite, but they're sillimanite internally. That's because they transform. But there's the final length, and the initial length, you just take up the two pieces of it. And you can do that, and you can calculate that the extension is about, or the stretch is about 2.75 on that particular surface. And you can use that to do various calculations. And we exploit that kind of thing in structural geology to quantify various things. And this is a spectacular example, but you can do it in a number of other ways. Folds also can be used in this context. Folds record shortening perpendicular to the line length. So one way to think of it is you could just take the line lengths here, around this as a measure of the shortening. Unfortunately, it's not quite that simple, and we'll deal with that too as we go along. But crudely, that's in effect material shortening in this direction and may or may not be stretching in this direction. But these particular rocks record fabrics. The strain is recorded as fabrics in those rocks. And so there's a relationship between folds themselves and the fabrics that are recognized in the rock. Here's one of my favorite examples of an illustration of simple shear that's a little bit more, that takes a different approach. That's still an illustration of the theory of finite strain. So I now covered it up, but we did it here before, right? Let's take the same one, right? You've got, in a shear zone, there's stretching in one direction and shortening in another direction, right? If you have veins that open up, opening perpendicular to the vein axis, that's the, what direction would that be? So look at a little vein here. Is there, I'm being too opaque, I'll just say it. There's a vein here that's opening in this direction, right? So vein is kind of the opposite of object rotating into the flow, but it's a brittle effect. But as the material opens, it's recording an effect that's a localized strain. And look at these guys here. These aren't just veins all through the rock. They are vein arrays. So they're bounded by undeformed rock on either side. There's one there, there's one there, and there's some up above. Those are referred to as en-echelon vein arrays. They're opening in this direction, and this is interpreted as a shearing. So what sense of motion is that by the theory? See, correct. I had to visually flip myself around. Right. That's correct. It's top to the right. It's the extension equivalent. The fabric or the shortening features would lie in this direction, but the stretching is in this direction. So there's a shear sense there that's again top to the right. And there's in other words, that opening is right there. Those can be very useful in rocks that are brittlely deformed because you can see the same effect. And we'll probably see examples of that in various field trips. Here's one that's fairly obvious. What's the relationship with this guy right here? connect the dots here, right?
Yeah, okay.
This is a small shear zone within a broader zone of shear, or shear band, as it's sometimes called. The rock itself is all flowed, but there are secondary zones of shear that are displacing features within this. That's a shear sense, same sort of thing. Top right. I think almost all my figures are. I'm dextral dominant here. I didn't mean to be. Okay, take a quick break. 5-minute break.